Afternoon's first speaker is, first presenter has been using Python for more than 10 years to build desktop and web applications. He's worked in a variety of organizations and has managed to use Python in all of them. Today he's going to be telling us about why he uses Py.test. Please welcome Andy Todd.
Thank you very much. Good afternoon. Hope the cakes were nice. So as I was introduced, the talk up there says why I use Py.test, and you probably should too. I'm actually going to speak about the subject I mentioned in the talk summary, but actually it's probably a different talk. What I should have said is this is how to start unit testing. It kind of changed as I wrote it, but I think that's probably a better description. Those of you who were in Ryan's talk in the plenary hall in the last session, if you understood what he was talking about there, this probably isn't the talk for you. This is for people like myself who've heard about unit testing and think it's a fantastic thing. But really, when it comes down to it, it's kind of hard to get started. I've written code for far too many years. I've written unit tests for that code for somewhat less, and I probably should have done more unit testing. So what I'm going to try and do today, for those of you who, like me, say 5 years ago, had never written any unit tests, is a quick overview of what unit testing is. A very quick tour through some of the libraries in Python, and we will talk about Py.test, because I think that's probably the best one to start with. We will then probably spend half of the talk talking about tips and techniques for how you can actually start adding unit tests either to a new application or to an existing set of code. And as I said, the key takeaway from this talk hopefully is some how do you start unit testing. And to help you along the way, I've done the Google search for you. How to start unit testing. Only 113 million hits. I've read all of them, so you don't have to. Interestingly enough, from a man who works in a Microsoft shop at an insurance company, there's an awful lot of stuff there for people who use C# and .NET. And if you like, that's a cultural thing, and I think testing is a cultural thing. If you go to the Java world, testing and unit testing and automated deployment is very big. In the Microsoft world, I think it's still got a way to catch up. Luckily, we're in Python, so everything's much easier, much simpler, and much better. Hopefully. So as I said, we'll just do a quick overview of some of the principles here in case there are people who haven't done unit testing yet. I'm sure you all have. What exactly is unit testing? And there's a few key principles. So here's the definition that I wrote. Well, it's based on the definition from Wikipedia. And there's a few key elements in unit testing that I think are important, and some of them are slightly less important. Probably the key word on that slide should be repeatable. Your unit tests, and unit tests essentially are code that tests code. Sometimes people don't think of it that way. Particularly should be isolated, and that is very important. If you go to the pure unit testing zealots, they'll tell you that every code should be completely independent of, every test should be completely independent of every other test. There should be no infection of one test to another. You can't share anything between your unit tests. Mostly that's true, and one of the reasons, and you'll see this later in the talk, that I recommend you use Py.test is because sometimes that can be a pain in the bum, and often it's preferable to share some elements, for instance, of your setup and your teardown between multiple unit tests, just otherwise it will take far too long to run a test suite. The next thing is they should be automated. You can't really see it on the picture there, but that's one of Google's fancy self-driving cars. I'm hoping they've written some tests for that software. But automation is important as well, because if you have to run each test by hand, you're not going to do it very often. What you want to be able to do with a unit test suite is basically just kick it off and run it every time. Again, if you get into test-driven development and fully embrace the methodology, you'll run the tests every time you check in a commit into your source code repository, hopefully. Maybe more often than that, as before you check it in. So automation is key here, because if you can't automate your tests, you're never going to run them. The other key component of unit testing, I think, is batching. Each test should test one thing and one thing only, but you will find as you go through and write unit tests for a piece of code or an application system, you will logically want to group things together. And what you, generally speaking, want to be able to do is, if you've only changed one part of a subsystem, you want the ability to run the batch of tests that affect that subsystem in your application, or one module in your library. You should by default run everything, but sometimes, again, the overhead of running a full suite of unit tests can be too much, and the ability to just break them up is quite good. So there was your 3-minute introduction to unit testing. I hope everyone was taking notes. In Python, we have a number of options to how we go about doing unit testing. Some of them are in the standard library. We love the standard library because it's free and it comes with every installation of Python. Some of them are not. Doesn't mean they're any better or any worse, it just means they're not in the standard library. So the first module from the standard library is the unit test framework. This has been in Python since 2.1. which, if my memory serves me correctly, came out somewhere around 2000. So I think we can safely say it's venerable. It's a very venerable module in the standard library. The only downside with unit tests is it's based on a Java framework. Not that that's a bad thing, but it has inherited some of those Javaisms which some people like, some people don't. Again, I'm not here to tell you that one library is better than another. There can be different tools for different circumstances. The standard library also has a module called Py.test, which is a different way of performing testing. It's based on essentially the principles of literate programming by some bloke who wrote a couple of books called Knuth. You may have heard of him. But essentially what that Py.test allows you to do is narrative testing. So you write a story, and within your story you embed bits of code, and then as you run your test suite, the bits of code are extracted and run against your application. Again, it's a completely different approach. You can do the same things in Py.test you can do in unit test, and vice versa. It really is horses for courses. The one test library that I like to use is called Py.test. It's not been around as long as unit test, but I think it's 7-8 years old. I must admit I forgot to check before this talk exactly how long it's been around. The key advantage of Py.test as opposed to unit test, and I'll show you this in some code samples in a minute, is that it's very, very easy to get started. And that was the point as I was writing this talk. I thought I should have changed the title. That's not to say that it doesn't allow you to do all sorts of complex things as well, because it has a full set of features. You can see some of them listed there on the slide, so I'm not going to read them out again. But one of the very attractive components in Py.test is the parameterization of tests. So if you want to run the same test with different parameters, you can do. We're not going to talk about that today unless you want to catch me afterwards. The key advantages, as far as I'm concerned, for Py.test are on that slide. I've mentioned that it's easy to get started. That's the less boilerplate. It has very, very simple unit test discovery. If you start doing lots of unit testing with the unit test library, you end up having to write your own test suite functions which capture all your tests from the different files and join them together and run them as a group. With Py.test, as long as you follow some simple conventions, you don't have to do any of that. It will just run all of your tests for you whenever you say Py.test on the command line. That's great. Saves me a lot of typing, and I'm all for saving typing. The other key thing that attracted me to Py.test when I started using it was I was doing a lot of work with databases, still do. Where you do strict unit testing and you have a database that needs to be in a set state before you start your unit test, you spend an awful lot of time setting up and tearing down that test state for each test that you run. And if you have a common state against which you want to run 100 tests, you do 100 setups and 100 teardowns. Kind of takes a while. With Py.test, you can put that setup, you have control over where you put that setup and tear down code. You can do it at the class level, so that class will contain a number of test functions, and the setup will only happen once at the beginning, run all those unit tests, and then you'll run the teardown. You can even do it at the module, so if you've got a bunch of test classes in your module, you can do some expensive setup work at the beginning, run all the classes in the module, then tear it all down at the end. That breaks the principle of isolation that I talked about 5 minutes ago. In the wrong hands, that could be a dangerous weapon, but I think given a situation where you have expensive resources and you want to use them carefully, it's a great bonus to using this library and this tool. I also talked about the full feature set as well. Some of the more advanced things you can do. Py.test has a plugin capability, which is fantastic, and people have done some very interesting and very strange things with that as well. The other point I'm going to make is contradict myself by saying actually the unit test library is going through a bit of a renaissance at the moment. And there's a new version of unit test in Python 3, which has been backported to Python 2.7, and that's called unit test 2. That includes the first 2 bullet points up there. So unit test 2, which I'll refer to it as, simplifies the unit test discovery based on essentially the way that Py.test does it. And it also allows you, if you want to pull out those setup and teardown code into different levels in your test code. Probably for the same reason that Py.test does it, because it makes sense in certain circumstances. Now, hopefully we can read that, that's good. Here is something that we are going to test. So this is the point of the talk where we say, well, how do I start testing things? Here's some code we're going to test. Please do not critique the code. You can come tell me afterwards how bad it is. This is a play school piece of code that I've set up specifically to show you some elements of unit testing. And essentially all it does is, in the body of that method there, it splits a string into a bunch of component parts. It's actually taken from a program that I wrote that none of you can see. That parses URIs into the various components so you can figure out which database you're connecting to and talk to your database. So what we're going to do is write some tests for this, and again give you some examples of how unit test and Py.test differ in their fundamental approaches and why I think Py.test has a better one. Not always, sometimes. So in our test module, using the unit test module from the Python standard library here, we start by importing our code that we want to test, because if you don't have it in the context, you can't run it. Obviously, we're importing the unit test module as well. What you'll see here is some features of the unit test library, which hopefully, if any of you have looked at unit test before, you'll recognize. The class that contains all our tests inherits from the unit test test case class. The method that is the test starts with the word test, although again that's not a convention. You can call them whatever you like in unit test, but by convention people tend to start with the word test. And it uses a method on the test case class called assert raises, and what that does, unless it's obvious from the name, is check that when you run the next bit of code it actually raises the assertion, so it raises the exception that you've mentioned in the first parameter. And essentially what we're trying to say here is if we pass in an invalid string to our function, it should raise a value error. If the code does raise a value error, that test will pass. If those of you who are paying attention to the last slide, you'll notice that there's no error checking in that code, so it won't, and that test will fail. That's probably a good thing, because if tests fail, it means we need to fix something. Very simple, very straightforward. If we want to test that our string has a :/ in it, you just add another method which goes tests that. Again, it's simple, it's straightforward. Your test code should not be very complex. If it's too complex, that probably means that your modules are too complex and you should be refactoring. Here's the same test in Py.test. Again, very similar. We import our code we want to test, we import the library we're using to test with, and then not very much else at all. Because Py.test does automatic test discovery, it will find in any module that starts with the name test, any class, function, or method that starts with the word test and try and run it. That's all it does. You don't need to have any inheritance, you don't need to have any boilerplate, you just put in the name test and it will be counted as a test. In a similar fashion to the unit test library, there's a special way to check for exceptions being raised. One of the differences between Py.test and unit test, which is important to people who write Py.test, maybe not so much to you and I, is that in the unit test library you have to use a special case assert. So if you just got standard assertions in your code, you can't your unit test code has to have the unit test assert method in it. For Py.test, you can just use normal asserts, unless you're trying to check for an exception, in which case you've got to use the Py.test raises. Hope that makes sense. And that Py.test test code was, hang on, I'm going to count the lines now, basically 4 lines of code. And back in unit test, you've got 9 lines of code. It's not a huge difference, but when you build that up over lots of modules and lots of components to your application system, it can be quite a significant amount of difference in the number of lines of code you write for your tests. And I'm all for writing less code and less lines of code. So I said this talk really should be how do I start unit testing. So I think we've all probably been there. You've got a module, you've got a script, you've got a library, you've got a couple of classes you threw together just to do some silly task. And you think, oh, I better do some tests for that because I'm going to hand it off to one of my colleagues, or I'm going to start using it a bit more seriously. Those classic sysadmin scripts that you just write once and then end up being a key part of your system. No one else has ever done that? Okay. But how do you start testing it? You get into something that's known in the trade as analysis paralysis. Analysis paralysis. Where do you start? How do do you sit there and work through every possible combination and permutation of the ways this code could run and ways that it could fail? And people will sit there and start going through that and then eventually go, oh, it's too hard. I'll go to the pub instead. And this is where I was at, and this is something that I think is important. So someone will say, I'm going to go, I'll just write some tests. But which ones? If you do sit down and try and write every possible test, and I'll talk about this a bit in a minute, for your code, you're going to miss something. So the next slide is probably the most important thing I'm going to say today, and some of you may know this already. It's what I call bug triage unit testing. And this is the way I started adding unit testing to a library that I maintain and then occasionally publish. And I read this on the internet somewhere. Apologies, I can't remember the exact original source of it. It's one of those common sense statements that eventually comes into law. What you do is when you have a bug reported or you find a bug and your code isn't working properly, don't fix the bug, write a test. The test should check that the behavior is correct, and therefore when you first run it, it will fail. So then you change your code until the test passes. And again, this is unit testing the hardcore way. You only change your code until the test passes. You don't do anything else. Once that test has passed, commit, save, deploy, you're all done. Then you get another bug, so you write another test. You then get another bug, you write another test. And eventually, because your code is, well, I'm sure all your code is perfect, mine is full of bugs. So when I get lots of bugs, I write lots of tests, and eventually I'll find that I've got a test suite over time that covers most of the key functions of the application. Sometimes you may want to add new features to your code. So how do you do that? You write a test that makes sure that if that new feature is working properly, the test will pass. You change your code until that test passes, and only until that test passes. And then repeat as necessary. You'll notice that the two slides are very similar. There's a reason for that, because it's quite simple. And if you follow those simple rules, you'll find that you will add tests to your code base incrementally, and over time it will build up and it will become a really useful tool in your arsenal. The other place where it's useful, and I found this the other day in some code I was trying to fix desperately because it was terrible, was when you start doing refactoring. And again, refactoring is something that some of us do more than others. I tend to repeat myself far too much, so I do this a lot. And you'll notice that those 3 lines of code there were actually they weren't just in 2 methods in my library, they were in about 5. So rather than having to write a test for each of those 5 methods, I just pull those 3 lines out into another method, wrote a couple of tests for that, all good. Sometimes it even works. Following on from the point about only change your code until the test passes, what we're doing here is, again, something that I was taught at university, is avoid premature optimization. If you're not touching a piece of code, you probably don't need to write tests for it right now, unless you're NASA or building control software for nuclear plants. Chances are, if you're not actively looking at a piece of code now, you're not really going to understand how you should be testing it anyway. Plus, this saves you from that analysis paralysis I talked about earlier, whereby you try and figure out every possible permutation and combination before you start. How long have I got? 5 minutes? Yeah. So a couple of more observations. So that's really, if you take nothing out of this talk, it was those 2 slides where it said, how do I start testing? Find a bug, write a test, change your code, fix it. Good. There are some other observations that come up when you start unit testing a library or an application system or even a module. And that's that code that has been tested starts to look different. You end up splitting your functionality out into more composable parts. And in fact, there's a fantastic quote I found on Stack Exchange when I was researching this talk. I'm not going to read it, I'll let you read that yourself. But essentially, again, I'm getting on a bit. So when I started, it was Unix or mainframe only. And I luckily worked in the Unix world. And one of the things that one of the people who taught me how to write code was the Unix philosophy. Have small, well-tested, well-executed pieces of code that you can join together. And what you'll find is if you start unit testing your code, that's what will happen. You will end up writing lots more methods or functions to join things together, but that's not such a bad thing. Final couple of points is where do you put your tests? Don't put your tests in the same files as your application code. You can. Py.test will run them. Bad idea. Put them in separate modules. Put them essentially in a separate package. So here's the Py.test code repository on Bitbucket. They've got a separate directory where all the test files go. That's a good thing. Do that. The other thing is you can retrofit tests to a big project. Again, I said one of the key reasons many people don't start unit testing is they go, well, I've got all this code and I don't want to start figuring out how to test it all. There's a great paper and the link's on there at the bottom. It's really easy to read, but I'll put these slides online, about how the LibreOffice project in their 4.0 release basically retrofitted tests to virtually every part of the application code. StarOffice and then OpenOffice basically hadn't done any testing at all. And in the 4.0 project for LibreOffice, they put in unit tests for everything. They will admit that they're not fantastic tests, but at least they have them. And one of their goals in the next release is to start improving those. You can do it. If they can do it, you can do it with your module. I kind of was sitting in Ryan's talk earlier and thinking, oh, blimey, here's the advanced testing tools. There's a lot of talks on testing at this PyCon, which I think is a fantastic thing because we should all do more of it. And I've really only just scraped the top of the iceberg, which I think is sitting out in the bay at the moment because it's that cold outside. There are lots and lots of things to talk about. Some of them will be touched on by other presenters in this PyCon. Others go out and find out about them. We've got things like test fixtures. How do you set up complicated state in your application system or environment so that you can then test the functionality within it? The whole concept of mocking is well supported in Python, is very useful if you're writing lots of tests against things like Twitter, I think was the example used earlier. How do you know you've got everything tested? There's a fantastic library by Ned Bouchelder called coverage.py. If you get a chance, have a look at that. It basically figures out how many tests you should have and how much of your code is covered by your unit tests. And then you get into the subject which Ryan talked about in his last talk, about things like continuous integration, stress testing, all sorts of other things. There's plenty of other stuff to read. One of the guys in the UK, that first link there, Obey the Testing Goat, is a work-in-progress book that's being published on the web. It's fantastic. It's how to do test-driven development using Django and Python. Really good. Lots of interesting stuff in there. It's being developed in the open, so you can all go and have a look at it now. And the other one, the next link, is probably also just as useful, the pythontesting.net site. They write some very interesting stuff about how to do things in different libraries, different approaches, that kind of stuff. There is a bunch of stuff. I put together a whole list of references when I was writing this talk. They're going to go on my website in a bit. That's just, the first half dozen of links. I just put them on the slide. There is a lot of stuff out there. You're not on your own. There's all sorts of useful information to be found. Finally, as I said, I'll put all this on my website, so that link is there. Hopefully there'll be a link to it. If not, I'll tweet it. That's my lot. We have got a minute for questions if anybody has any, and there's a microphone, I believe.
Just for someone that's a bit new with testing, but I've just done a little bit with nose tests. How does Py.test differ, or how is it the same?
Thanks for the question. They got a different approach. Nose was written because of the it's a test collection library is what Nose really is. And it was built because test collection in the unit test library was a bit too hard. It's kind of changed since it was originally written, but that was the purpose. It was Nose will find and run your unit tests for you. You can actually use it as a front end on a number of unit testing libraries, but that's really the difference.
One of the primary problems with testing is the data that you test against.
Sorry, say that again? Didn't catch it.
One of the primary problems when getting started with testing is the data that you test it against. So I know Py.test has fixtures, but is there any way in order to conveniently create fixtures of whatever you want to do? And how do you go about including the particular data for the testing, particularly if you don't know about, for a particular data it is failing. So how do you get that in?
So how do you set up state? I mean, test fixtures, I guess, is just a generic term for how do you set up the environment so that your tests run, and part of that can be including setting specific sets of data in, say, a database or a file store. There are a number of libraries for that. Probably the most sophisticated one, I think I put it on the last slide, is written by a chap called Robert Collins, who's actually at the conference. Did I put a link to it on there? Test Tools is Robert's package, which contains a number of things. Specifically, it's got a test fixture library in it. And the one on the simplistic link called Test Fixtures also is very good. Slightly different approach, but they're both very good for setting up the state, so databases, file stores, NoSQL databases, that kind of thing. Okay, I think we're all done. Thank you very much. Coffee, excellent.
So on behalf of PyCon Australia, I'd like to give you this
coffee
from Ritual.
A lovely mug.
A lovely mug.
Cheers, thanks.
Thanks very much. Thank you.